Hello everyone, a very warm welcome to our channel. Well, in today's video, we're going to deal with the second part of matrices. If you haven't watched the first video, please rush up and watch that. The topics that we're going to cover today are the properties of addition of matrices. Then we have scalar multiple of matrix, properties of scalar multiplication of matrix. And then we have questions on addition of matrices, and then we have questions on multiplication of matrices. Let's quickly begin. Before we begin with the properties of addition of matrices, here are quick things that you must know while solving the addition of matrices. Firstly, the order of matrix must be same. The order of matrix must be same for both the matrices that you're going to add. Now let's say I have 1, 2, 3, 4 and I have 5, 6, 7, 8. These two can be added. But if I say 1, 2, 3, 4 and on the other hand I have 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, if you're wondering if I can actually solve this matrix, no, it is not possible, because for adding matrices, you must make sure that the order of the matrix must be same. Here you have 2 cross 2 and here you have 2 cross 2. So addition is possible over here. On the other hand, we have 2 cross 2 and 3 cross 3 over here, which is impossible to solve. Now let's see a quick question of how to solve the matrices. Okay, now if I have 1, 2, 3, 4 and 5, 6, 7, 8. Now if I'm going to add these two matrices, how am I going to do that? Well, you're going to add 1 and 5 first. First, let's make a new matrix, that is, the output of solving these two matrices. So 1 plus 5 gives you 6. So let's put on 6 first. Then you have 2 plus 6, that is 8. Right? Then we have 3 plus 7, that is 10. And lastly, we have 4 plus 8, that is 12. Now, I hope you understood how to solve the addition of matrices. Now, let's quickly dive into the properties of this addition of matrices. Firstly, we have commutative property, which says A plus B is equal to B plus A. Now, in our lower classes, we must have studied this property, right? Which says 2 plus 3 is equal to 3 plus 2. Right? I'm just going with the normal numbers. I'll also show you with the matrices. Now here we have 5 equals to 5. This is the commutative property, which says even if you change the order of the numbers, let's say this is A plus B will be equal to B plus A. This is the commutative property. Here A is 2 and B is 3. Now let's put this into matrices. Let's have a quick example now. Here we have 1, 2, 3, 4 plus 5, 6, 7, 8. Now, if you're going to solve this, you'll certainly get 6, 9, 9 and 12, isn't it? Why did I get that? 1 plus 5 is 6. 2 plus 7 is 9. 3 plus 6 is 9 again. And then we have 4 plus 8, which is 12. Now, let's put this aside for a while. Let's just note down this answer, which says 6, 9, 9, 12. This is my matrix. Now, if I reverse the order, firstly, we have commutative property, which says A plus B equals to B plus A. Before we dive into the addition of matrices and their properties, first let me talk about commutative property, which we have studied in our lower grades. Well, 2 plus 3 is 5. Now if I change the order of the digits, let's say I say it as 3 plus 2, it will still be equal to 5, isn't it? Now I'll put this into matrices. This is what is the commutative property of natural numbers that we have studied in our low grades. Now let's talk about the commutative property of matrices. Now I have matrix 1 which says 1, 2, 3, 4. And I have matrix 2 which says 5, 6, 7, 8. Now the addition of this will give you 6, 8, 10, 12. Now you'll tell me how. Here 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, 4 plus 8 is 12. That is how we got this answer. Now what if I reverse this matrices? How do I do that? I'll write 5, 6, 7, 8 first plus 1, 2, 3, 4. Now let's add them and check out the result, right? So here we have 5 plus 1 which is 6, 6 plus 2 which is 8, 7 plus 3 which is 10 and 8 plus 4 which is 12. Now if you look at the result, they are same. That means they are equal. Even if you change the order of the digits, they are equal. So this is what is the commutative property of addition of matrices. Now let me dive into associative property, which says A plus B plus C in brackets is equal to A plus B in brackets plus C. Now what does this mean? It seems quite confusing. Let us dive into the basics first. Let's implement into the natural numbers. Now if I have 3 plus 2 plus 5. Now come on, tell me, what will this be equal to? It will be, you're going to follow the board mass rule, which says brackets first, right? You're going to solve the brackets first. B for brackets, right? And then we have brackets of division, multiplication, addition, and subtraction. This is something you already know. Now if I solve the brackets first, we have 3 plus 7, which is 10, isn't it? Now if I change the order of the brackets, if I put it in this order, it's gonna be 3 plus 2 plus 5, isn't it? Now what is this equal to? This is equal to 5 plus 5, which is 10. Now if you have a look at this result and this result, aren't they same? They are same. Now let's put this into the matrices. Let's say I have 1, 2, 3, 4 plus 5, 6, 7, 8 plus 0, 0, 0, 0. Let's make our calculation simpler. Alright, you can still have a complex number. That's an exception. Now if I'm going to solve this, first I'm going to solve the brackets. Now you know that anything, if you add it to 0, it's going to be the same number, that is 5, 6, 7, 8, right? That is going to be your matrix. Now your new matrix is going to be 1, 2, 3, 4 plus 5, 6, 7, 8. Now if you're going to add this, you get 6, 8, 10, 12. This is our matrix result 1. Now if I change the order of the matrices, that is if I say 1, 2, 3, 4, if I put this in brackets, right? 1, 2, 3, 4 plus 5, 6, 7, 8 plus 0, 0, 0, 0. Alright. Now this is gonna be, firstly, we're gonna solve the brackets. This is gonna be 6, 8, 10, 12. Isn't it? Then we have plus 0, 0, 0, 0, which is nothing but 6, 8, 10, 12 again. Right? This is result number 2. compare result number 1 and result number 2 are in the same, they are equal, right? So this is the associative property. Now this is quite simpler. When we talk about the additive identity, it means a plus 0 equal to 0 plus a. Now what does this mean? If I say I have a matrix A which is 1, 5, 7, 9, alright, if I'm going to add it with 0, here 0 does not mean plus 0. No, not at all. Whenever I'm talking about 0, it means I'm talking about the 0 matrix. Alright, how is a 0 matrix formed? 0, 0, 0, 0. Now this will be equal to 1, 5, 7, 9, isn't it? How? 1 plus 0 is 1, 5 plus 0 is 5, 7 plus 0 is 7, 9 plus 0 is 9. So this is what we got. Now I'm going to change the order. I'm going to say 0, 0, 0, 0 plus 1, 5, 7, 9. If I say this, it's still going to be the same. Let's look how. 0 plus 1 will give you 1. 0 plus 5, 5. 0 plus 7, 7. 0 plus 9 is 9. Now, if you have a look at the results that we have, they are simply equal. So, this is the additive identity of addition of matrices. Now, I'll say additive inverse. Now, one thing that you're going to make sure over here is that if I have a matrix 1, 2, 3, 4, alright, it's additive inverse. Now the examiner will ask the additive inverse of this matrix. So it's simply going to be equal to minus 1, minus 2, minus 3, minus 4. That means the inverse of 1 will be minus 1. The inverse of 2 will be minus 2. The inverse of 3 will be minus 3. And the inverse of 4 will be minus 4. Now this identity says if you're going to add these two, that is if you're going to add the A and the inverse of A, then they'll be equal to 0. Let's see how. 1 plus of minus 1 will give you 0, isn't it? 2 plus of minus 2 will give you 0. 3 plus of minus 3 will give you 0 again. 4 plus of minus 4 will give you 0. So here 0 does not mean simply 0. It is the 0 matrix. Alright, this is the 0 matrix. So this is gonna be your result. Alright, this is the additive inverse of the addition of matrices. Now we're done with the properties of addition. Let's quickly dive into the scalar multiple of matrix. Now, what is the scalar multiple of matrices? Well, now let's say I have 1, 3, 5, 7. Alright, this is one matrix. Now, if I'm going to multiply it with one scalar quantity, that is if I have 2, then how do I perform multiplication for such cases? You're going to multiply 2 with each element. You're going to multiply 2 with each element in the matrix. Alright, so that is going to be equal to, now the first element is 1. So 2 times 1 is 2. 2 times 3 is 6. 2 times 5 is 10. And 2 times 7 is 14. Now this is how you're going to perform the scalar multiple of matrices. This is how you're going to multiply them, right? You're simply going to multiply the scalar one with every element in the matrix. So 2 times 1 will give you 2, 2 times 3 will give you 6, 2 times 5 will give you 10, and 2 times 7 will give you 14. Now we are done with scalar multiple of matrix. Let's quickly dive into the properties of scalar multiplication. Now the first property says alpha into beta A in brackets, and then we have alpha beta in brackets into A. Here all the things which are in yellow, those are matrices, and you must always remember that matrices are denoted in capitals, capital letters. Alright, this is something I'm gonna put in mind. Alright, now let's implement this particular property. Alright, Now I'm going to take alpha as 2 and beta as 3. Alright. I'm going to simply substitute them. And then I'm going to add one matrix and show you this property. Well, let's say 2 into 3 into matrix I have over here is 1, 2, 3, 4. Let's say I'm going to put this in a square bracket. Alright. Hold on. Yes. So this is simply going to be equal to 2 into 3, 6, 9, 12. Why? Because I have multiplied 3 with each term in the matrix. So this is going to be equal to, I'm going to now multiply 2 with each element. Are you getting? So this is going to be equal to 6, 12, 18, 24. Now this is how we have implemented in the first part of the equation. Now if you're going to implement this in the right hand side, that is alpha beta into a, right? You're going to put alpha and beta in brackets right now. Alright, so 2 into 3 will be in brackets, and on the other hand you have the matrix which is 1, 2, 3, 4. Alright, now you're going to first solve the bracket which is 2 into 3, that is 6 into 1, 2, 3, 4, which is simply going to give us 6, 12, 18, 24. Now if you have a comparison of the results that we got, they are simply equal. And this is the first property of scalar multiple of a matrix. Moving ahead, we have alpha plus beta into a is equal to alpha a plus beta a. Here I'm going to take alpha as 2, beta as 3, and matrix we're going to substitute it however. Well, 2 plus 3 in brackets, into we have 1, 2, 3, 4 again. So this is going to give us 5 into 1, 2, 3, 4, which is 5, 10, 15, 20. So this is our result 1. Now if you put this in alpha a plus beta a, then it is going to be 2 into 1, 2, 3, 4 plus 3 into 1, 2, 3, 4. It's simply going to be the same result. Let's see how. So this is 2, 6, 6 and 8, right? Plus this is 3, 6, 9, 12, isn't it? Well, have a look at this. Here we have put 3, we're going to put 2, isn't it? Because our matrix was 1, 2, 3, 4. So 2 2s is going to be 4. Alright, now you're going to add them. You simply know how to perform addition. So this is going to be 5, 10, 15 and 20. So if you have a comparison of the results, they are simply equal. So alpha plus beta into a is nothing but alpha a plus beta. So it can also be solved in this manner. So this is the second property of scalar multiple of a matrix. Then we have alpha into a plus b is equal to alpha a plus alpha b. Now here a and b are two different matrices. Now firstly, let's say alpha is 2. Then I'm going to put two matrices over here in brackets, that too. So this is going to be 1, 2, 3, 4, let's say. And let's say 5, 6, 7, 8. Fine. Now if I'm going to solve this, first I'm going to solve the brackets, isn't it? So this is going to be 6, 8, 10, 12. Now if you're going to multiply 2 with each element, then it's going to be 12, 16, 20 and 24. Isn't it? Then this can be further simplified as alpha a plus alpha b. Substitute that next. Then you have 2 into alpha alpha is nothing but 2, right? So A matrix, that is 1, 2, 3, 4, plus 2 into B matrix, that is 5, 6, 7, 8. Now this is simply going to be equal to, first solve this, and then add up. Alright. So 2, 4, 6, 8 plus 10, 12, 17, 16. Sorry, this is going to be 14, right? 14 and 16. Now, how did I get that? I'm going to multiply 2 with each element, right? 2 5 is 10, 2 6 12, 2 7 is 14, and 2 8 is 16. Now, simply add them up. 2 plus 10 will give you 12. 4 plus 12 will give you 16. 6 plus 14 will give you 20, and 8 plus 16 will give you 24. Now the results are same. This is the third property of scalar multiple of a matrix. Now if you have a look at this is something very easy again. Here whenever I'm talking about 0, again I'm reminding you I'm talking about 0 matrix. Alright. Now if I have 2 into 0, 0, 0, 0, then you're going to multiply 2 with each element. Then that's simply nothing but 2 into 0, 0, 2 into 0, 0, 2 into 0, 0, and 2 into 0 is 0. So this is the 0 matrix. This is the fourth property of the scalar multiple of a matrix. Then here it says 0 into A equals 0. Now what does this mean? 0, 0, 0, 0 into, I have a different matrix, which is, let's say, 1, 2, 3, 4. Now 1 times 0 is 0. 0 times 2, 0. 0 times 3, 0. And 0 times 4 is 0. So whenever I'm talking about 0, I simply mean it is a 0 matrix. Alright. So this is the fifth property of the scalar multiple of a matrix. Now here we completed 1, 2 and 3. Now we're going to dive into the questions of addition of matrices. Here we move to the question number 1, which says 2, 9, 5, 1 minus 9, 5 and 17. Now if you're going to add them up, it's going to be 2 plus 1, which is 3, right? Then you have 9 plus of minus 9, which is 0. Then you have 5 plus 5, which is 10. And then you have 1 plus 17, which is 18. So this is how you're going to add two matrices. Here, the order of this matrix is 2 by 2 and this matrix is also 2 by 2. And that is why addition is actually possible for these two matrices. Now here we have the order of matrix as 3 cross 3 and 3 cross 3. So addition is possible. Now let's see how to add these, right? Minus 1 plus 1 will give you 0. 1 plus 1 is 2. 4 plus 4 is 8. Then you have 0 plus 9, which is 9. Minus 1 plus of minus 2, which is minus 3. 7 plus 7, which is 14. 3 plus 2, which is 5. 2 plus 2, which is 4. Minus 6 plus of minus 6, which is minus 12. So this is how you're going to add matrices of the order 3 cross 3. Now here we have the last question in the addition of matrices. Here the order of this matrix is 3 cross 3 and the order of this matrix is 2 cross 2. Now I have been repeatedly telling, if the order of the matrix is different, if it is not same, then addition is not possible. Alright. Here the order of matrix is 3 cross 3. Here it is 2 cross 2, which is impossible to solve. Moving to the last topic of today, which is the questions on multiplication of matrices. Let's quickly dive into it. Now here you have the questions on multiplication of matrices. Here you have 2, 9, 5, 1, 1 minus 9, 5 and 17. Here this is row 1 and this is row 2. For multiplying two matrices, first take the row 1, that is 2 and 9. You're going to multiply row 1 with both the columns of matrix 2. So firstly multiply row 1 with column 1, which means 2 into 1 plus 9 into 5. What have we done? 2 into 1 is 2, 9 into 5 is 45. You're going to add them up, alright, which is going to be 47. So simultaneously let's form the new matrix, which is going to have 47 first. Then secondly we have row 1 with column 2 of second matrix, that is this column. So this is going to be 2 into minus 9 plus 9 into 17. This is going to be minus 18 plus 153, which is 135. Alright. So you're going to have 135 over here. This is 135. Then there is nothing to do with row 1 right now. Alright. Let's quickly erase this. Then we have process with row 2. Now you're going to multiply row 2 with both the columns of second matrix. That is going to be equal to 5 into 1 plus 1 into 5 plus 1 into 5. That is going to be equal to 5 plus 5, which is 10. So here you're going to have 10. Moving forward, we have 5, 1, which is going to be multiplied with minus 9, 17. That is the second column of second matrix. So 5 into minus 9 plus 1 into 17. This is going to be equal to minus 45 plus 17. This is minus 28. So here you're going to have minus 28. So this is how you're going to multiply two matrices. Firstly, take the first row and multiply with the two columns of second matrix. Then take row 2 and multiply with the two columns of second matrix. That is how you got a 2 by 2 output again. So if the question has 2 by 2 into 2 by 2, then your output is going to be in 2 by 2 manner. So for the multiplication of matrices which have the order 3 by 3, right, the output is definitely going to be in the order 3 by 3. Alright, that is the first thing. Secondly, how do we multiply 3 by 3 matrices? Well, here first take the first row and multiply with all the columns of the second matrix. Firstly, we're going to multiply first row with first column of second matrix. That is going to be 1 into 1. This is going to be minus 1 into 1, right? Minus 1 into 1 plus 1 into 9 plus 4 into 2. So this is going to be equal to minus 1 plus 9 plus 8. This is 8 plus 8, which is equal to 16. So the output matrix will have 16 as its first element. Then we are going to multiply row 1 with column 2. Alright, we are going to multiply row 1 with column 2, that is 1 minus 2 and 2. So this is going to be minus 1 into 9. Well, this is going to be minus 1 into 1. That is because here we have 1. So minus 1 into 1 plus 1 into minus 2 plus 4 into 2. Alright, this is going to be minus 1 minus 2 plus 8. This is minus 3 plus 8, which is 5. So here we are going to have 5 as our second element. And then we're going to multiply row 1 with column 3 of second matrix. Alright, so this is going to be minus 1 into 4 plus 1 into 7 plus 4 into minus 6. Now if we simplify this further, we have minus 4 plus 7 minus 24. So this is 3 minus 24, which is minus 21. So we have minus 21 as our third element. Then you're going to take row 2 and multiply with all the 3 columns. Okay, firstly, let's take the first column. Let's do it a little bit quicker, because you know the idea of the problem. So 0 into 1 plus minus 1 into 9 plus 7 into 2. What is this going to be equal to? Minus 9 plus 14, which is 5. Alright, so this is going to be equal to 5. Over here, it's going to be 5. Then when we move on to the second column, let's quickly erase the first one. Alright. When we move on to the second column, we have 0 into 1 again plus minus 1 into minus 2 plus 7 into 2. What is this going to be equal to? 2 plus 14, which is 16. So here you're going to have 16. Then row 2 with column 3 of second matrix. Right? So this is going to be equal to 0 into 4 plus minus 1 into 7 plus 7 into minus 6. 7 into minus 6. Alright, what is this gonna be equal to? Minus 7 minus what is 7 times 6? It is 42. Alright, this is gonna be equal to minus 49. Now third row with the 3 columns. Alright, so it's gonna be 3 into 1 plus 2 into 9 plus minus 6 into 2. So this is going to be equal to 3 plus 18 minus 12. This is 3 plus 6, which is equal to 9. So here you're going to have 9. Alright. Then we move on to row 3 with second column of second matrix. That is going to be 3 into 1 plus 2 into minus 2 plus minus 6 into 2. Isn't it? So now this is going to be equal to 3 minus 4 minus 12. This is minus 1 minus 12, which is minus 13. So here you're going to have minus 13. Then we have third row with third column. Alright. So this is going to be 3 into 4. Isn't it? 3 into 4 plus 2 into 7 plus minus 6 into minus 6. Now what is this equal to? This is equal to 12 plus 14 plus 36. That is equal to 62, isn't it? So this is going to be 62 over here. In this manner, you're going to solve 3 by 3 matrices and you're going to perform the multiplication of them. So this is your final output of the multiplication of these two matrices. You have 16, 5, minus 21, 5, 16, minus 49, 9, minus 13 and 62. Well, that dives to the extreme end of this video. Don't forget to like, share and subscribe.